Hello everyone, I'm a Japanese YouTuber Kawahara. I'm making some videos on mathematics, physics, philosophy, and so on. Well, this time I'd like to give an introduction to IUT theory, IUT, Universal Terminal Theory, developed by Professor Mochizuki. 8 years ago, he he released a preprint giving a proof of ABC conjecture by the theory. Recently, it's accepted in a journal. Last April. But the validity of the proof is still under discussion. Anyway, let's see the statement of the conjecture. This is it. ABC conjecture. Well, let ABC be positive coprime integers and a plus b equals to c and epsilon be positive, which is fixed. Well, then there are at most finite number of tuples ABC, which hold this. Radical of ABC to the 1 plus epsilon is less than c. Okay? Well, you may wonder, what does it mean? What's radical? So let's see it. Okay. Well, let n be positive integer, which is factored as such. P1 to the R1, P2 to the R2, PS to the RS. Then radical of n is P1 times P2 times PS. In other words, it's the product of prime factors of n. Let's see example. 1. In case n equals 72. 72 is factored as such. 2 cubed, 3 squared. So, radical of 72 is 2 times 3. That is 6. Well, and the next case, 300. And 300 is 2 squared, 3, 5 squared. So, the radical of 300 is equal to 2 times 3 times 5. That is 30. Okay? Well, let's see more. Okay. Next case is 16. 16 is 2 to the 4th. So radical of 16 is 2. Okay. And the last case, 1. N equal 1. 1 doesn't have any prime factors. So radical of 1 is equal to 1. Okay, that's radical. Well, then what's the statement? What does it mean? Well, to make it simple, let's think of the case epsilon is 0. Well, of course, it's not the case with the original statement, which assumes epsilon is positive. But to make it simple, let's think of the case epsilon is 0. Then the statement turns to be that in most cases, radical of ABC is greater than or equal to C. Well, so let's check it. Well, let's see some examples. Oh. First case is in case ABC is 358. In this case, ABC is equal to 120, and radical of 120 is equal to 30, which is greater than 8. So, in this case, it holds. And the next one, ABC equal to 5712. Then ABC equal to 420. And radical of 420 is 210, which is greater than 12. So it holds. Okay. And the next case, ABC equal to 5, 13, 18. In this case, ABC is equal to 1,170. And radical of the number is 390, which is greater than 18. So it holds, okay? But how about this case? 189. Well, in this case, ABC is equal to 72, and radical of 72 is equal to 6. Okay, 6, which is less than 9. So this is an exception. Well, and let's see the next case. ABC equal to 1, 2 to the 6n minus 1, and 2 to the 6n. Well, in this case, ABC is equal to 2 to the 6n times b. And 9 divides b. So b is equal to 9 times b over 9. Okay? So radical of 2 to the 6n times b is less than or equal to 2 times 3 times radical of b over 9, which is less than or equal to 2 times 3 times b over 9, which is equal to 2 over 3 times b, which is less than c. So this is exceptions, and well, n can be any positive integers. Okay, so oh, so when epsilon is 0, there are infinitely many exceptions. But the conjecture tells that if epsilon is positive, there will be at most finite number of exceptions. That's the statement. Okay? And Mochizuki claims its proof by the theory. And what's the IUT theory? Wow. It's let's see the essence of IUT. Well, this is a world of mathematics. Suppose this is the world of mathematics, and there are some small worlds, small universe. Okay. Then this is a object, mathematical object. Wow. We don't know where it is. It can be here or here, here. Oh, we don't know. Well, we don't know. But if it makes some relationships to these worlds, then by the relationships, the location of object is tend to be around here. So we can get some information on this object. We can get some information. Well, this is the essence of IUT theory. Okay. Let's think of this case. This equation, x equals to 2x minus 1. Well, it's an easy one. Well, the both sides number related to x. Left hand side is x itself, and right hand side is also a number related to x, and the both sides are related in the by equal. So x is determined. Okay. Well, this is just like a man. X is just like a man, and who is stepping on his own shoelace. So he cannot move. So his location is determined. Well, likewise, x is determined. Determined. In this case, x is 1. Okay. Then we're going to do the similar thing. Well, suppose x is some information. Some information. Well, some information. Like data or structures, or algorithms, and so on. X is such something. And this X is projected to two worlds, two universes, U1 and U2. X1 in U1 and X2 in U2. U1 and U2 are related. The relationship is called theta link. Okay. Well, we want to compare x1 and x2, like the equation. Well, but to compare x1 and x2, we have to transmit x1 to u2 because u1 was in x1 was in u1 world. But to compare x1 and x2, we have to transmit x1 to u2 world. But during transmission, some data are broken, like such, like this case. When we carry egg, sometimes it often get broken. Well, so we have to put X1 in a capsule. X1 in a capsule. Like such case. Well, packed eggs. Okay. When packed, we can carry safely. Okay. Well, the X1, X2 in capsules. But still, some information is lost, like such case. Well, X in expect, but when they go through microwave, they are boiled. They change in quality. In other words, some information is lost. So two universes are not enough. We have to provide more universes. In fact, infinite universes. And we project X to these worlds. x1, x2, x3, ta. Each in capsules. Each word. And the words are related in data links. Well, then we can get some information like this case. Okay, we can get some information. Well, what kind of information is X? Well, that's for example, number fields or arithmetic line bundles and so on. And what about capsules? That's, for example, functions or log shells. Log shells are part of number fields. Function, log shells, and so on. And this, in this way, we can get some information like such. X is bound in many universes. So we can get some information about X. This is the essence of IUT theory. Okay? That's it. Well, thank you for watching. So, thank you very much. See you next time. Bye.